let's go for this. So, last time we were talking about water, and we were seeing things that are uh, important, that are useful, that are in water, and then things that are harmful that are found in water. You must know this: the harmful substances, and it's very big. Uh, there are a lot of marks. When you get these questions, you may get a lot of marks. I'm sure Eric would tell you the questions he sent me. A lot of marks. Okay. Either way, we are continuing. The last time we were talking about eutrophication, and I'm sure everybody remembers it. Okay, and what I had just taught you was the most important thing to say. Water has dissolved oxygen. It's a beneficial substance. It's needed by fish. Fish need the oxygen in water. They need it for respiration, and other aquatic organisms need it. Now the problem is, if you have um, excess nitrates, excess phosphates, which are from here, here, excess nitrates and phosphates, we say that these will speed up growth of things that we don't want in the water. This will promote excessive growth of plants in water. Now that will promote deoxygenation, because these plants also want that oxygen. Once there's excessive plant growth, they cause deoxygenation of water, and now the plant, now the aquatic life does not have the dissolved oxygen in water, and that is damaging the plant life, and that is what we call eutrophication. So if we put summary of important versus harmful things, let me write fast. And I don't want to speak in a way that anybody will sleep. I have to make sure all of you are hearing me. And we talk about water treatment and important things. It's not too much. And we talk about air. So let's write as fast as we can. Beneficial substances versus harmful substances found in water. Okay? Can be found in our natural water. Natural water is not pure. What are the things that you can find? Beneficial. One, dissolved oxygen. Beneficial thing number two, calcium, magnesium, potassium. Mm, these group 1 and group 2 ions. Okay, you can say calcium ions, magnesium ions, potassium ions, sodium ions, all found in water, right? Metal ions, useful metal ions, essential metal ions. Then comes to the toxic, bad things found in water. You can just say toxic metals. Toxic metals. Then you have sewage. Then you have plastics. Okay. Then you have 4 and 5 would be nitrates and phosphates. You can say excess nitrates, because the other ones will be used by the plants. But there are some that will remain in the soil, and those are washed away. Excess nitrates and excess phosphates. These are harmful substances that, when you find them in water, they mean no good. They will do no good. Really? Yes. Right. Now let's go to the next part. Water treatment. Water treatment. Okay. Water treatment. Why do we need to treat water? Why? Untreated water contains insoluble impurities. Untreated water has insoluble impurities. Okay? And I say examples. E.g., sand, soil, and plant material. In brackets, you put it. And also, untreated water has soluble impurities. And also, soluble impurities. What are those? Dissolved ions and excess pollutants. Dissolved ions and excess pollutants. Which dissolved ions? The bad ones. Not the beneficial ones. The bad ones. The nitrates in excess, the phosphates, and all these other things. These are found in untreated water. So, therefore, water must be treated. Okay. Now, water treatment has 3 stages. Water treatment has 3 stages. First one, the first stage of water treatment is called sedimentation and filtration. This is the easy one. What it's to do is to remove the insoluble solids in the water. Okay? So, say to remove insoluble solids. So, stage 1, the sedimentation, is to remove insoluble solids. Stage 2 is carbon filtration. Stage 2 is carbon filtration. Stage 2 is carbon filtration. Okay? To remove tastes and odors. Carbon filtration is to remove taste and odors. Then now comes the last one. Okay? Don't worry. Let's put it. Last one is stage 3. Chlorination. And this is to kill microbes. Chlorination is now the last and final step, which is to kill microbes. Small microorganisms that will cause cholera, typhoid, these bad diseases. You cannot have them in 2026. Come on now. They have to be removed from the water, those microbes that cause such things. Okay? So, this is the third one. Chlorination. Chlorination. So let's go through it. Okay? Then you'll be done. I'll be happy. Let me write fast. Stage 1, sedimentation. Stage 1, sedimentation. We can put infiltration, the first basic one. Okay. Then we have carbon filtration alone. Still fine. Excuse me. So, what do you do when you do sedimentation? It just means you let heavy things fall down to the bottom. Okay, you let the water be alone, and you let the heavy things fall down to the bottom. So let's have it. So the water is put in large tanks. The water is put in large tanks. I need to drink water. Okay. Right. Tastes better. Water is put in large tanks, and materials heavy materials in the water are allowed, say heavy particles rather, or materials, whatever it's the same, are allowed to sink, okay, to the bottom. When I say heavy particles, I want you to put e.g. mud, sand, okay, soil, same thing as mud, but yeah, okay. These form sediment. Okay? So this is going to be the very first thing you do. You allow the heavy things to sink. All together. So when we say they form sediment, we mean they form solids. Okay? Solid particles. Sediment is a solid particle. Okay. Do you hear me? Hello? It's like an insoluble particle. Okay? So let me say solid particles that settle at the bottom of a liquid. That's what we do. Okay? Or a liquid mixture. They form a suspension. You know where they cannot dissolve in the liquid. So you allow them to fall to the bottom, and that is what we'll be now calling the sediment. So they go to the bottom, and now we have a sediment. Yeah. Then, okay, then you do filtration as well. You can put it as this part. Okay. Right. So you now say water, then passes through sand and gravel, okay, to remove smaller particles. You pass it through sand and gravel and you collect it at the bottom. The sand and the gravel will collect the smaller particles. Are we together, students? Hmm? The sand and the gravel will collect the smaller particles out of it, okay? Do you people know gravel? Gravel is like tiny rocks. Do you know gravel? Tiny rocks that are used when they are building, or they can be used to like design walking places, walking paths and stuff. That's just gravel, tiny rocks together. Even like pebbles on the beach, and you bring them together, and you have a bunch of them. That's like what we mean. So you're gonna pass the water through that sand and gravel, and that's filtering off, okay, to remove smaller particles or off filter off smaller particles. Are you seeing what they're doing in the water treatment? Are we together here? Can you see what's going on? Exactly. Sedimentation, and then you pass them through gravel. Right. We'll keep moving. Can't stop. What is the next thing? Say carbon filtration. Step 2. Step 2. Or stage 2 of water treatment. Stage 2 is to remove odor. Okay. Carbon filtration. Which carbon? Charcoal. Pass it through charcoal so that the water does not stink. To try and have water which doesn't stink. Say here, water is made to pass through. Water is made to pass through charcoal. That's carbon. Don't let me down. I want you to know that charcoal and that black carbon you see, it's carbon. That right there is carbon. So water is made to pass through charcoal, okay? And what is the purpose? Okay, to remove unpleasant tastes and odors. To remove unpleasant tastes and odors. Now we have one thing left. Microbes. That's the only thing. And we now say stage 3. Chlorination. Now what I want you to know is that this stage where you make water pass through sand and gravel sometimes is its own. After sedimentation, sometimes they say this is step through, you pass it through sand and gravel. Then step 3, you pass it through charcoal. So in that case, there will be 4 steps when we are dealing with water treatment. So it can happen. We'll answer accordingly. Here now, we say microorganisms. Why do we need chlorine? Because we have microorganisms that are too small to remove completely by filtration. Microorganisms are too small to remove completely by filtration. We have filtered and filtered, but there's still some things that can cause cholera. Hey, So don't drink that water yet. Therefore, chlorine is added to remove or to kill. Chlorine is added to kill microbes and prevent your typhoids and your choleras and your all these things that are very, very harmful. Okay? So when I just say microbes, I just want you to say here tiny, tiny living things, tiny living organisms like bacteria, fungi, viruses, okay, algae, protists, tiny living organisms that are too small to see with the naked eye. Too small to see with the naked eye. Okay, you can say e.g. bacteria, fungi, viruses, okay, etc. Algae, some that is too small to see with our naked eye. All this chlorine will say, don't worry, I can handle these ones. These ones I'm not leaving them. So now we chlorinate the water. Chlorination. Okay? You don't have to know about how the process is done, but you must just know that is what is done. And that is what it does. Okay? So we can say this helps prevent cholera and typhoid, etc. Cholera is a very painful disease. You'll be having a stomach ache, a painful one, and somebody will be sick as well, and it wants to kill. Cholera is there to kill. It's not a friend. It's not a friend. Cholera is not a friend. So it wants to kill. Are we together, students? So these are the things. Have you seen? Lou. If you put a table of the steps, you can say treatment or stage. You can put one, sedimentation, and filtration. You can say sand or gravel filtration. Then carbon filtration. Then chlorination. Sedimentation, large particles allowed to settle at the bottom of the liquid. To settle. This one, remove small particles. The large ones are gone. They are heavy, they fell to the bottom. But you still have small ones that are floating. Don't worry about them. You remove them using sand or gravel filtration. Then you get to carbon filtration. This is simply to remove smells or tastes that are unpleasant. Then you get to chlorination. It's to kill microbes. Once you have this, then we say, well done, my friend. Well done. You now know the treatment of water. So if they ask you treatment and function or purpose, here are the reasons, and here is the treatment. And you should know this. If you know this, you now know the treatment of water. What's left is for us to now talk about um, fertilizers and air. And this is not going to be even a problem, okay? We'll make sure we look into that in our next lesson, and we'll be done with this chapter. And we move on to even more things. We keep going through all the hard things, and we see how far we can go. Anyone with a question? Who has a question here? Nobody? Are we fine with water now? Okay. The test for water using cobalt chloride and copper sulfate? Yes, I think you know. Talking about pure water, its melting point, boiling point, talked about it. How to make distilled water, we talked about it. We talked about aquifers. We talked about important things found in water, dissolved oxygen, all these things. We talked about how nitrates and phosphates can cause eutrophication. We've talked about water treatment. So we are done. Now, what is left is to now look at fertilizers, and you need to know something called NPK, nitrogen, phosphorus, potassium. K is for potassium. Then we'll just teach you those things. Um, and then we look at air, and we're done. So that is our next focus. So camp is here, is over.